Okay, this is the second page of your Cornell notes on transport. The second page says, what are a solute, a solvent, and a solution? We talked about these terms during chapter 2 when we were learning about water and biochemistry. But this top one got cut off a little bit. Osmosis, we're going to write that in for you. That was back on page 1. Osmosis is the diffusion of water across a semi-permeable membrane from an area of high concentration to an area of low concentration. The terms solute, solvent, and solution we talked about in chapter 2. The easiest way for me to remember this stuff is that a solvent is the substance that's present in a greater amount. It's usually water, because water is the universal solvent. The solute is the thing that's being dissolved into the solvent, and the solution is finally the homogeneous mixture. So our chocolate milk example, the solute would be milk, the solvent would be chocolate, and the solution would be chocolate milk. So this was just a review. What is a hypertonic solution, hypotonic solution, and isotonic solution? I really feel like pictures help with describing these things, and this is what you're going to be looking closely at when you complete the understanding osmosis sheet for the gummy bears. Hypertonic solution has a high concentration in relation to the cell. So in a hypertonic solution, there's your cell, and it's shrinking because the solute concentration is higher on the outside. So the water that's inside of the cell wants to get out there and kind of make even the concentration of water on both sides. So I think about hypertonic solutions, and I think about like Chinese food. When you eat Chinese food, you feel really thirsty because you've eaten a very high sodium food. It's got a lot of salt in it. So your cells are kind of shrinking down. The water from inside of your cells is coming out into your blood. You kind of get like swollen because a lot of the water from your cells is coming out into your bloodstream because it's trying to even out that concentration of solutes. So if there's lots of, let's say, salt or sodium floating around in there, your blood cells are going to shrink because the water is going to come out of the cell. So in a hypertonic solution, the cell becomes hypotonic and it shrinks. In a hypotonic solution, you have a low solute concentration in relation to the cell. So in a hypotonic solution, it's like you drank a whole lot of water and your concentration of solutes are thinned out a little bit. You don't have a lot of sodium swimming around in your cells, and your red blood cells are going to begin to swell. The concentration is greater on the inside of the cell, so water goes into the cell. An isotonic solution is when things are just right. You've got an even concentration of solutes inside the cell and outside the cell. So everything is just right. There's a proper flow of solutes and water into and out of the cell. So isotonic is just right. Hypotonic is going to make the cell swell. Hypertonic is going to make the cell shrink. And that's just the descriptions of the solutions in relation to the concentration inside of the cell. It's kind of a tough concept to get. I encourage you to watch one of the videos that are on the materials section of Schoology if you need a little bit more clarification on this. Down at the bottom of your page are also images that show hypertonic, isotonic, and hypotonic, what occurs to the cell in each of those solutions. So this concludes your transport Cornell notes. Make sure this is finished in your overview, and if you have any questions about anything, again, post them in the updates section under comments in Schoology so I can take a look at those and go over them with you. Again, this is a really important diagram to have in your notes and have memorized, and it will really help you get ready for the test.